pre-algebra lesson, 6-1, ratios and unit rates. Make sure you write down these vocabulary words with their definitions to be ensured that you will have them in your notes for future reference. A ratio is a comparison of two quantities by division. It can be written in 3 ways. You can write it A to B using words. You can write it A colon B, or you can write it like a fraction, A over B. However, all of them are read A to B. Whether you write it with the word to, with the colon, or with the fraction bar, it is still referred to as A to B. A rate is a ratio that compares quantities of different units. For example, 250 words in 20 minutes, or 6 miles per 1 hour. Okay. It's a ratio that compares quantities in different units. A unit rate means that the rate has a denominator of 1, like my 6 miles per 1 hour. That is a unit rate because it has a denominator of 1. If I say I can type 240 words in 20 minutes, if I made that as to a denominator of 1, then I can type 12 words per minute. And that would be a unit rate. A unit rate must have a denominator of 1. Ratios and unit rates. There's a very important rule about ratios that you need to make sure you fully understand. Ratios are always written in lowest terms. However, they are never, ever, 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 ever changed to a mixed number. Because a ratio is comparing two quantities. I cannot compare two quantities if I'm not talking about 1.5. If I have 3 boys for every 2 girls, I can't have 1.5 boys for every girl. Does that mean half a boy shows up, his top half, his bottom half, his left half, his right half? I don't think so. Therefore, you never, ever, ever change them to a mixed number. All ratios and rates are left as improper or proper fractions. Now, let's look at writing some ratios and rates. We're going to write each ratio as a fraction in the simplest form. We're going to refer to the table at the right. This is a table, and people either said they had a job or didn't have a job. 40 people have a job, 60 people do not have a job, which means there's 100 people who were surveyed. We're going to make a ratio of all the students surveyed to students without jobs. Well, all the students surveyed were 100 students. So there's 100 students that were surveyed, and of those 100 students who do not have jobs, that's 60. This is an improper fraction. Again, we will not change it to a mixed number, but we will reduce it. Okay? I know this will reduce by 20. 20 goes into 100 5 times. 20 goes into 60 3 times. So there's a 5-to-3 ratio. For every 5 students surveyed, 3 did not have a job. That's what this means. That's what a ratio means. You understand the common bond behind what the number actually stands for. Now let's make a ratio out of all the students surveyed to students with jobs. Well, all the students surveyed is 100 again. Those who had jobs was 40. Again, I can divide by 20. 100 divided by 20 is 5. 40 divided by 20 is 2. So there's a 5-to-2 ratio. For every 5 students I talk to, 2 of them should have jobs. That's what that ratio means. The last ratio we're going to talk about is students with jobs to students without jobs. Students who have jobs, that's 40. Students who do not have jobs, that's 60. So again, I can divide by 20. This is a 2/3 ratio. 2 out of 3 students surveyed have a job. That's basically what that stands for. Okay, the table on the right shows prices for different packages of index cards. We want to find which size is the best value. Now remember, I did say in this chapter you can use a calculator, provided you show me all the steps, and we will outline what steps those happen to be in this particular problem. So in order to figure out which size of cards has the best deal, I have to compare them and find the unit price for each one. Okay, I need to convert to a unit price to find the cheapest unit price. So I'm going to find the unit price for each one of the sizes of cards. To find a unit price, that would be cost over different size. And sometimes that's cost over pounds, sometimes it's ounces. In this case, it happens to be number of cards. So we have 3 different sizes. I'll just call them A, B, and C, just to make it easier. The cost for 100 cards is $2.70. So I have $2.70 over 100, which should be able to be divided without even having to use your calculator. But in case you have to use your calculator, you just take 2.70 and divide it by 100. Exactly what you see up here is what you put into your calculator. 2.70 divided by 100 is going to be 0.027 cents per card. So it's about almost 3 cents per card. Okay, almost, not really. Okay, so we leave it as 0.027. Even though we don't have a thousandth of a penny, we leave it out to the thousandths place value because sometimes you need to go that far to be able to compare a unit price. Okay, and by the way, I'm going to make these that one A, this one B, this one's going to be C. So B, we charge $1.30 for 50 cards. So again, I'll put on my calculator 1.30 and divide it by 50, and I'll get 0.026 per card. So basically 2.6 cents per card. You know, you can't have a tenth of a cent. You can talk about it like data, you just can't own one because there is no tenth of a cent. And C is there's 75 cents for 25 cards. So we'll take 0.75 on our calculator, divided by 25, and we'll get 0.03 cents per card. And these are exactly what things I would need to see on your paper to prove that you actually plugged them in your calculator. You need to tell me what you would put into your calculator. And obviously what you got as a result out of your calculator. So if we look at these 3, clearly there is one that's a little cheaper than the rest of them. Okay, so which size is the best value? The best value is the 50 card size. So we would write the 50 card size is the cheapest. Now, remember before when we used dimensional analysis to be able to figure out how many feet there were in 12 miles or how many ounces there are in 4 pounds? We're going to do the same thing here to be able to convert unit rates, different rates in the customary system. You can use the same method to convert unit rates. If I say I need to convert 30 gallons per minute, 2 cups per second, I'm simply going to put 30 gallons over here, over 1 minute on the bottom. And I need to remember some of my conversion rates. I personally don't know how many cups are in a gallon, but I do know that there are 2 cups in a pint, 2 pints in a quart, and 4 quarts in a gallon, so I might actually have to do that conversion. Okay, if there are 2 cups in 1 pint, 2 pints in 1 quart, and 4 quarts in 1 gallon. Notice pints cancel, quarts cancel, so there are 2 times 2, which is 4, times 4, which is 16. So there's 16 cups in 1 gallon. So I can multiply this by 16 cups in 1 gallon. And now I have cups per minute, just like I need, because it said I need so many gallons per minute, 2 cups per, I need cups per second. Okay, so I need to convert to seconds. So, how many seconds are in a minute? Well, there's 60, so I know that 60 needs to either go on the top or the bottom. I need the minutes to cancel out, just like I have the gallons cancel out here. So if I need the minutes to cancel out, I would put 1 minute on the top here and 60 seconds on the bottom here so that my minutes cancel out, and now I have cups per second. So I can simply multiply 30 times 16 over 60 times 1. Okay, 30 times 16 is 480 over 60. That tells me there are 480 cups in 60 seconds, but I don't need 60 seconds. I need 1 second. So we'll divide 480 by 60. And we will get 8 cups per second. And I would expect to see all of this work in your homework. I'm allowing you to use a calculator, which means all the computations are now very easy, which means I need to know what you are doing to get to your answers so that I can tell whether or not you're doing the proper setup. So it's very, very important. Let's look at this next problem. We're going to convert 3.5 quarts per minute to gallons per hour. Okay, so I'm going to simply write exactly what I see. 3.5 quarts in 1 minute. And I can't convert both of them at the same time. I need to convert quarts to gallons, and then I need to convert minutes to hours. It doesn't matter which one I convert first, but you cannot convert them simultaneously, not at the same time. So I do know that there are 4 quarts in 1 gallon. So 4 quarts should go on the bottom because I need the quarts to cancel out. So the gallon goes on top. Now my quarts have canceled. Now I've got gallons per minute, but I need gallons per hour. How many minutes are there in an hour? Well, there are 60 minutes in an hour. Since I need the minutes to cancel out, the 60 minutes should be on the top here. And the hour should be on the bottom here. So the minutes cancel out right there. And I now have gallons per hour, which is what I was last to find. So I'm going to take 3.5, multiply that by 1, and multiply that by 60. So that's going to give me 210 gallons per 4 hours. But I don't want to know how many gallons there are in 4 hours. I want to know how many gallons in 1 hour. So take 210 and divide it by 4, and you're going to get 52.5 gallons per hour, which is what I was asked to find. How many gallons per 1 hour? Now we're going to look at 12 centimeters per second and change that to meters per hour, not miles per hour. There's no I there. So 12 centimeters per 1 second. And how many centimeters are in a meter? Well, there are 100 centimeters per meter. So 100 centimeters would go on the bottom. So we need the centimeters to cancel out. 1 millimeter would go on the top. So now my centimeters are canceled out. And there are, there are 60 seconds in 1 minute. And then there are 60 minutes in 1 hour. So I'm going to put 60 seconds here. 1 minute. And then there are 60 minutes. Okay, so now my seconds are canceled out. And I need 60 minutes in 1 hour. I get my label in there. So now my minutes have canceled out. So I have 12 times 60. Oops, not 66. Let me try that again. 12 times 60 times 60 divided by 100. So 12 times 60 times 60 is 43,200 divided by 100. That tells me how many meters per 100 hours, but I don't want to know how many meters per 100 hours. I want to know how many meters per 1 hour. So I have to divide by 100. And if I divide by 100, I get 432 meters per hour. Last thing we're going to do is talk about finding a unit rate. To find a unit rate, much like we did with the index card problem, all you're going to do is divide until you have a denominator of 1. If it deals with money, money always goes on the top, and the other item always goes on the bottom, whether that's a size or a time or whatever. If it deals with something else, just think in normal terms. Do we name things in miles per hour or hours per mile? It all depends on the situation you're in. Okay? If I have 2 liters of spring water for $1.98, that's cost, $1.98, over size, 2 liters. Always put labels in unit rates. You must, always label. So 1.98, divide that by 2, and you're going to get 99 cents per liter. And that's a unit rate. And I always put my liters in cursive so it doesn't look like a 1 and get confused. 425 miles on 12.5 gallons of gas. Well, I know that when we're talking mileage, we're talking miles per gallon. Whenever you buy a new car, they're always telling you, oh, this car gets 40 miles per gallon, or this car gets 80 miles per gallon. So we're going to do miles per gallon, so I'm going to put the 425 miles on the top and divide that by the number of gallons on the bottom. So I will stick 425 on my calculator, and I'll divide it by 12.5, and I will get 34 miles per gallon. Or you could write it 34 miles per gallon as mpg. Either way is fine. I do not have a preference as to which way you write it, but it's down to the unit rate. Unit rates aren't hard, especially when you use a calculator, because you just need to know how to do the computation. The calculator, as long as you plug it in carefully, does the computation for you.